Hi guys, today we're going to be looking at usaco-training street race IOI 95. Okay. So in this problem you're basically going to be given n plus 1 points that forms a graph. So the points are labeled from 0 to n, and in this case n is equal to 9. As you can see, the nodes are labeled 1, 2, 3, 4, 5, 6, 7, 8, 9. And this graph is supposed to form some race with point 0 as the start and point n as the finish, or the destination. So the arrows represent one-way streets, which basically mean that the edges are one direction only. Yeah, so you can basically move from one point to another point if there is a street, or basically if there's an edge. So here's the thing. Every point in the middle, except from the start, can be reached from the start using some edges. The finish point, which is point n, can be reached from each point, basically each other point. And the finish has nothing going out of it, so you can't reach any node from point n. So yeah, so there are some points that are unavoidable, which means that every path from the first node, which is 0 to n, there's a set of nodes that each path has to visit. So for example, you must visit the start node, so 0 is an option. For 3, if you notice, any path must go through this 3. And so, same thing goes for 6 and 9. And if you look at it, however, let's just say 4 in this case, you can have a path that doesn't go through 4, so it's not considered in this set. So first thing you need to find is the set of unavoidable points. Second thing you need to find is basically the number of splitting points. So basically what it is that so this is in the context of a race, and you start from point 0 and then you have to finish at some splitting point. So then on the second day you go from the splitting point to point n, and you have to find the splitting point. So what are the criteria of these splitting points? So it's a splitting point if it's not the start or end node, and the course can also be split up into two well-formed courses that do not have any common edges, and they have S as their only common point. So with S as their finish and start. So yeah, so 3 is a splitting point. Alright. Okay. So yeah. Okay, so let's look at this input format. So it's a bit odd because like there's not really a clear instruction, but here's the thing. So the first line is going to be the outgoing edges from node 0, and this is node 1, node 2. So if you notice, like it says every line ends with a -2. So every time you see a -2, you know that it's the end of this node, and once you reach a -1, you know that it's the end of the input. And okay, so now you have to output it. So yeah, so first line is you have to output the set of unavoidable points. So in this case it's going to be well, I'll draw this out later, but if it was the above case, it would be 0, 3, 6, 9. But then yeah, but then you actually don't output the start and end, so you only output 3 and 6 for the case over here. And second line is that you output the splitting points, so that's going to be in the above case it's going to be 3. Okay, so yeah, so let's see. how we can work through this problem. All right, so first thing is that we want to draw this graph. So the graph in the sample, we have one node, 0, and it goes to 1 and also goes to 2. From 1, it goes to 3. 2 also goes to 3. From node 3, you go to nodes 4 and nodes 5. From node 5, you can go to, from node 4, you can go to node 4 and node 6. From 5, you can go to 6. 6, go to 7, go to 8. From 8, from 7, you can go to 9. From 8, let's see. So you can go to 5, you can go to 9. Alright. Okay, so this is our graph, and if you look at it, this is a splitting point. This is an unavoidable point because in order to go from 0 to 9, you must visit 3, and so it's 6. But now let's look at the splitting points. Basically, what you can see is that 3 counts as a splitting point because from 0 you can go to 3, and you can, because the thing is that for a splitting point to meet its condition, it has to be an unavoidable point as well, or else you're going to have some other, or if this is not an unavoidable point, then there would be some other node that you can visit, but then all the paths have to, because on day 1 everything has to end here, so this wouldn't work. But of course that's not the case here, so yeah. Okay, so but now the thing is that 6 in this case isn't a splitting point, and that's because basically because if you start from 6, because the thing is that every path does have to go through node 6 as well, but the thing is that on day 1 you have to go from 0 to 6, and that works. But on day 2, what would happen is that you might go through this path, which is to node 8 to node 5, but then you can't go to any node on day 1, so then that wouldn't really work. Okay. So let's actually break this problem down into like these 2 portions, like finding, we want to find the unavoidable points, and 2, the splitting points. Alright. Okay, so unavoidable points. So here's the thing. So we want to consider a path from 0 to n. And what happens is that you have this node, let's just call this I. And for every path, it must go through I, and it must go from I to n. And we're also given that n is reachable from 0. It's guaranteed in the original graph. So what happens when you remove I? So then if you remove I, and there's no more path from 0 to n, then it means that it's unavoidable. And that's because all the paths have to pass through I, so if I is removed, then it's an unavoidable point. So basically, if I is removed and there's no path from 0 to n, then I is an unavoidable point. Because if we consider it, if there's like some other path from 0 to n, then there would still be a path, but then it wouldn't be like unavoidable because there was originally a point. I mean, there's a path that doesn't use it. So that's pretty important. And to actually find this in your actual code, you can actually just use something like DFS. Let's use blue here. You can use like DFS or like BFS, your preference, and then basically you still you start from 0 and then you just keep on searching. But if you see I, you just don't like insert I into your next DFS or BFS. Yeah, so that's what you would use for that. All right, okay. But now the harder part is kind of finding the splitting points. Okay, so basically what you want to do is that from 0, okay, let's just say, because for a splitting point you can actually loop through each node and you want to check if it's a splitting point. So now we're talking about splitting points. Okay, so now again we have 0, we have n, and we have some I. So the thing about a splitting point is that it's basically broken down into a 2-day race basically. So you have to go from 0 to I, and then you have to go from I to n. So first thing a node has to be when it's a splitting point is that it has to be an unavoidable point. Because if it's not an unavoidable point, then like some person could just skip this node because it's supposed to be the ending node of day 1, but at the end of day 1, someone could just already use another path that didn't use it. So first thing, it has to be an unavoidable point. So using this, we can actually kind of find this if it's an unavoidable point or not. And then next thing we have to do is that we have to check that starting from I, which is your midpoint, because let's see, let me draw an example. So actually we can use this 6 example, because first thing you know is that it's an unavoidable point. So let's see, 6 is unavoidable. And the thing that makes this not a splitting point is that it has this path to 8, which leads back to 5. So basically, starting from an unavoidable point, you can't reach a point that's reachable in day 1. Okay, so let me write that down here. So second thing is that you can't go to a point from I that's reachable in day 1. So for example, over here the problem is this node 5, because in day 1 you might go through 0.5, but in day 2 you can't actually go through 0.5 again. So that's the problem here. So that's why 6 isn't. But if we consider node 3, this set of nodes is in day 1, and this set of nodes is in day 2, so that works. So you have to basically check this condition, condition here, that it has to be unavoidable and you can't go through any point. So to do this, you also use DFS, or BFS, but you start from point I, and the thing is that you want to check the number of points that's reachable, or you actually want to know for each specific point if it's reachable from I. So again, using you do two BFSs. One is from I, and one is from 0. And you see that if there is any common point, and you have to notice that 0, if you pass through I, you cannot use this. You cannot go further. So you like what you're going to do to check this case, you're going to apply the same kind of DFS when you run it from 0. And yeah, now that if you calculate your splitting and your unavoidable points, then you're basically set for this problem. So let's see how we're going to implement this. Ooh. Alright, this is kind of glitchy. So yeah, so first thing that might be a bit difficult is finding the input. So so basically, because you're not really given the number of points that you have, you're just given this thing, and you're going to end with a -1. So what you can do is that we start from node 0, and then basically you want to read some I. Let's just say we have a edge from node 0 to node 1. So we're going to do scanf is reading an integer I, and what this returns is the number of keys that it read. So if it's successful, it'll read I. And yeah, so what you do next is basically you have to do some casework. So if the thing you read is a -2, it means that the number of nodes have increased. So you increase n, right? So if it's -1, then it means that you're ending, so it can just break. Otherwise, you basically want to add an edge from n to I, because n is the current node that you're on. So what you want to do is that the maximum n is 150 points. Yeah, 50, and we have some kind of adjacency list. And so to add an edge from that, you can use a vector like what I'm doing, and you push I into that. Okay, so that's basically our input. Yeah. Okay, so now we need to find the unavoidable points. So first thing you know is that node 1 and the last node can't be the unavoidable point, so you have to loop through I from 1. You can actually just do that. And so these are possible, and now we need to check. So now we do a DFS. Okay, so let's define DFS as like we kind of traverse. So we start from I, and then we just go to every other node that we can reach, and we mark it as that, okay, we can reach that node. So then to do this, you just loop through each j, and if, let's call this marked, so if not marked j, then we DFS j. And at the start of this, we say that, okay, we can visit node I, so we just mark it. Okay. So yeah, so here's the thing. First thing to check if it's unavoidable is that it can't pass through I. So if node I over here is ignored, then it can't go to n. So it only goes through if it's already marked, if other nodes are already marked. So what you can do is that we can just say, okay, I is already marked, and then we DFS from 0. So now if if we can't reach the last node, then it means that I is unavoidable. Alright, so now we can have like we can just push this to our answer. Okay. So next thing is that we need to find if it's a splitting point. So so a splitting point must be unavoidable, and you can't go through any other point starting from that splitting node that can be visited in the first starting from 0. So what you can do is that you can actually reuse the DFSC over here to find marked, and yeah, so that's our current marked. So what you can do is that you can have another array. So this is basically marked from 0, and basically at the end of this you can first copy this to your marked 0. So what you can do is that for each node you can just say marked 0, right? And then what you do is that you reset this mark because you want to use it later. So now you basically saved your marked 0, and now you want to make another DFS, but you want to start at I. Okay. So you start at I, and then you fill up your new marked. So now let's call this splitting, and let's just say originally it's 1. So now again you loop through each of the nodes. So basically you want it so that if it can be basically visited by I, and if it can also be visited by your original marked, then your splitting is false, because if I can reach this and J can also reach this, then it's invalid. Or if I can also reach it and 0. So basically if it's splitting, then you can make, let's just say split. Let's just say split, and then you push this into our answer. And yeah, so the thing you have to watch out is that after you DFS, you kind of want to reset your marked, or else it might be reused next time. So you just have to set it to 0, just like what you did here, but you actually want to do J. Alright, so now at the end you have to output your answer. So the format they want you to do is the size of the points, which is unavoidable but size, and you want to convert that to an integer, and then you output the nodes new line, and then you do the same for splitting, and you also put that out. Yeah. Okay, now let's test this. Hopefully this works. Okay, so it says all the points are unavoidable. Now let's see what's up here. So marked I. So first thing I want to see is that if the edges are correct. So that's our edge. Okay, so 0 to 1, 0 to 2, 1 to 3. Okay, so I think this makes sense. Let's see, 0, 1, and you see that, so it would increment to the next one. So now let's print out the total number of nodes. Oops. So it says it's 10, which is correct. You have 10 nodes. Okay, so if not marked. Okay, so what we want to do here is that it's not marked at 0 because you want to use, because we actually already reset this, so you have to change this to 0 as well. So, okay, so correctly it says that 3 and 6 are unavoidable, but now the problem is our splitting points. Okay, so let's see. Okay, oh, I see. So the problem here is that I can reach node I. So basically I can reach I because it's the starting node. So once you go in, it's already gonna mark it. And then from above, marked 0. So 0 can also reach I. So that's gonna be a problem here because you don't actually want it to count. So you have to make sure that if I is not equal to j, and then you check this condition. Okay, so that works. Now let's submit this. This is brace 3. And yeah, I don't know how to, I forgot how to do this. Is it task? Yeah, it should work. I'm not sure. Oh yeah, uppercase, I forgot. Where is that? Let's see. Oops, it's a typo. Oh, just gonna use 14. Alright. Okay, yeah, so that works. Thanks for watching. Have a good day. See ya.